Hi guys, and welcome to the first in the preliminary chemistry series on the topic of metals. In the first of these videos, I want to concentrate on basically a little bit of an overview of metals throughout history, look at a comparison between some of the early uses of metals and the more contemporary ones, and also why certain metals have a much longer history than others. So firstly, to look at the ages of metals, I guess the oldest is gold, and gold has been around for a very long time, partly because it's such a beautiful material to work with. It's very soft, it's very stable, so it doesn't react, and it looks great. And I guess in addition to all of these reasons, it's still relatively rare. Okay, if we had lots and lots of gold, then I guess its price wouldn't be as high as it is currently. Gold is known as far back as the Egyptians, and if you've done any study of history, you'll know how much gold was used by the Egyptians, particularly in their burial rites, and in fact how important that metal was. Now, most of the key ages, I guess, have their tracings into regions in the Middle East. They were the areas that were most heavily populated, and also where a lot of material was being mined. So the first important age was the Copper Age. Copper is, relatively speaking, a low activity metal, so we do find it in its native form as well as combined as an ore. And the Copper Age stretched back over around about 4,000 years as things started to be made from copper and copper alloys. Probably the most important copper alloy and the discovery of the fact that you could actually improve some of the properties of copper was by adding other materials to it. And that brought in the Bronze Age, and that's why you can see there's a little bit of an overlap in the timing here, because copper is one of the key metals in bronze. So bronze started to increase the strength of the metals. So we started with gold, which was very, very soft. Copper was a little bit stronger. Bronze, stronger again. So now we could have things that were starting to be sharpened, and we were starting to think about using some of these for warfare. Beyond bronze is iron, and iron is really the age of weaponry. Lots of iron and iron ores have been used for steels, spears, swords, arrowheads, those sorts of things. And so this meant that we had significant change in the types of materials that we could make from metals. The modern age is about, well, the last 2,000 years, and it's been characterized by a very rapid growth in our understanding of different types of elements, particularly metals, and ones that we've discovered through additional processes of refinement and decomposition. And we'll have a look at some of those a little bit later. What's with the future? Well, we kind of will contextualize our discussion of the future around some of the important metals that have been found more recently and some of the uses that they've been put to. So the first most important one we need to talk about is the Copper Age. Copper, as I mentioned, has a very long history, not quite as long as gold, but pretty close. And one of the reasons for that is that copper is found as a free element. It's actually found in what we call its native form, which means uncombined. So you can find copper as the copper element, but you can also find it as a compound locked up in an ore, and chalcopyrite is probably the most common ore. Chalcopyrite has both copper and iron present, whereas chalcocite has just the copper in combination with sulfur. Copper metals have been extracted from their ores, from their mineral ores, through the process of smelting, which basically means heating in a furnace in the presence of carbon. So charcoal is just carbon, and the carbon is going to combine with the sulfur, or sometimes we've also used it to combine with oxygen, to remove that and leave us with the pure copper. The uses of copper over time have changed a little bit. So the ancients tend to use the first copper for fish hooks, for pins and jewelry, so fairly small objects that they could shape. And it's the shaping which we've called malleability, which is a key physical property of copper that lends itself to these sorts of things. But of course, the hardness of copper in relation to certainly gold meant that tool making was something else that was starting to come along for the ancients. Now copper is our best conductor for the use in homes for electrical wiring, so copper still tends to be the most dominant metal used for electrical wiring, but we can have a lot of saucepans and things with copper bases on them, so the base being copper to I guess improve that conductivity. Water pipes and different types of plumbing devices, and also some ornaments. Ornaments, a bit of a problem. One of the things with copper is it tends to go a little green through deposits of verdigris, and this is basically an oxidizing of the copper, which can leave it with a little bit of discoloration and usually of a greenish color. After the Copper Age was the Bronze Age. First of all, what we discovered, or what was discovered in the Middle East, was that sometimes with the copper there would be other materials being combined, and when we tried to heat to remove some of those, sometimes what happened is that other elements like arsenic or tin actually got incorporated with the copper and formed an alloy. We'll have a look at alloys in the next video, but the thing with these is that it improved the strength. And so bronze is where we start looking at things like cutting tools, so we could put a nice edge on these, and also for weaponry. So things that were harder and therefore more resistant to damage could be used as weapons. And so the Bronze Age, I guess, was the age that ushered in some fairly serious wars, because now wars could be fought over particular types of metals in particular, and with devices that were actually going to give a particular side an advantage. So bronze was really where it started. The other problem, of course, is that to form the nicest of the bronzes is to alloy copper with tin. And whilst most of the ages that we see were centered around the Middle East, the ore that contains tin, the most common ore, which is cassiterite, was not found around the Middle East. In fact, it was found in Europe, in places like England. So it had to be imported or exported out of where it was and imported into the Middle East. And of course, that meant trade, but it also meant strength and people wishing to take areas of land for themselves. Beyond the Bronze Age came the Iron Age, and iron in particular was an extraordinarily good substance, not only because it was another step forward from bronze, but in particular, again, in its alloyed form. So iron ores and iron alloys, very important in producing some very important materials. So initially, iron ore was used for the development of chariot wheels or barrel hoops, for simple things like nails and knives or sickle blades, but also in areas of warfare and weaponry. Now swords could be made from iron that were hard again and sharp, so hard and sharp, and improved those wars that were already starting to be fought over different types of ores, and so therefore sources of each of these different types of materials. But iron and its alloys were also very useful in terms of the strength that they had. and as a consequence was starting to be used for all sorts of different types of machinery and also for building construction, which is still what we use steel for today. And we know that there are stainless steels, which tends to be used more in things like cutlery, whereas some of the more stronger steels tend to be used in building frames and roofing and so on. One of the quite important modern materials, modern metals, is titanium. Titanium is a silvery white metal. It has low density, high tensile strength, and also high corrosion resistance. This one has now been used to replace quite a lot of the previously used metals. The problem with titanium is we didn't discover it until quite late because it's not found freely in nature. It's not a native element, and as a consequence of that, we were unable to identify this particular metal until, well, very late in the 18th century. It tends to be locked up in beach sand, so the source of most titanium is beach sand, so either as rutile or ilmenite. So you can see these are compounds containing titanium. And titanium is very lightweight and also very strong. And this has meant it's been used in, say, bicycle frames, lots of other sporting equipment too, like golf clubs, tennis rackets and those sorts of things, because of its lightweight and because of its high strength. And of course, we know, or we probably don't know, but we will know when we look at alloys, that the whole purpose of alloying different types of metals is to take advantage of the different physical properties that each of those individual metals have and produce something that's better through combination. So when you alloy titanium, it becomes stronger, in fact 30% stronger than steel, which is, I guess, its comparison point, and very, very extraordinary resistance to metal fatigue, so unlikely to crack and break on you. The problem with titanium, and the reason it's probably not more widespread than it is currently, is it's a difficult metal to work with and it's reasonably expensive. So there's two important questions, I guess, to be pondering as you complete watching this video. The first is why you think there are more metals available now than there were 200 years ago. And to answer a question like that, you want to look at the history. So the fact that most of the early ones were all about either native metals, so ones that were found uncombined, or ones that could be produced through a low temperature smelting. Okay, now low temperature smelting could be 200, 300 degrees as opposed to 500, 600, 800 degrees Celsius. And so as we developed more high temperature furnaces, so we were able to extract more of these metals. But the biggest problem is that the activity of some metals is so high that even just heating them up isn't enough to decompose them. The strength of the bonds between the metal and its other elements is so high that the amount of energy required to break those bonds can, in some cases, just be too high to achieve with just heating. So as a consequence, we had to make sure that, first of all, we were able to build smelters or blast furnaces that were able to reach much higher temperatures. We also recognized that there was a way we could break material compounds in particular down through electrolysis. And we've looked at an example of that with water in the previous topic. And also, we've started to produce particular metals that are a consequence of nuclear bombardment. So the firing of particles into the nucleus of certain types of atoms can occasionally allow them to retain those additional ones, and as a consequence we've been able to produce a number of new materials. The other thing to be aware of is that this section talks about possible future uses of metals, what might become important and why. And of course this is crystal ball gazing, so there's no right or wrong answer here. It's just about considering applications of technology, the fact that I'm producing this particular video with computer screens, with all sorts of different devices that are mostly made from metals or alloys. that we can communicate this, and we can communicate not only to people we live next door to or in the same city as, but around the world. And again, metals play a role in that, in moving material and people from one place to another, and also in the construction of houses, cars, boats, planes, trains, all sorts of different things. So when you're looking at suggesting possible future uses, again, no right or wrong answer, but have a think about what we're currently using and what sort of things we might be looking for in the future. Thanks for watching.